Hello everyone, welcome once again to our lessons, our chemistry lessons. Today we are going to look at electrolysis of solutions. We shall look at electrolysis of solutions, and solutions are basically substances in liquid state. They are basically substances in liquid state, and we are going to perform a simple experiment here using some locally available materials that we have at home. Remember, we are working at home with this pandemic that has gotten into our country. So we are all working at home, or not all, but most of us are working at home. And remember that our students are at home, so it is important for us to encourage them to watch this so that they can continue learning as we fight this pandemic. Now today we are going to have the electrolysis of sodium chloride solution. Sodium chloride solution. What do we need? We need some water to make our solution. We need sodium chloride. And remember, sodium chloride is available in our homes, which we normally call common salt. So this just a salt, some salt that we have picked in our kitchen that we shall use. Then we shall have a beaker, and of course I have improvised the beaker. It is just a tin that I have picked from my kitchen. And we have a battery and some connecting wires and connecting wires. Now, in this one, we have more than one ions that are present in our solution. So we will have our sodium ions. We shall also have our chloride ions. And because we are putting it in water, water is also providing us some extra ions. So we are going to have the hydrogen ions, and we shall also have the OH ions, or the hydroxyl ions, from water. So today we are going to look at more than 2 types of ions that are being electrolyzed. So let us go ahead and connect our apparatus. We are also going to have our masking tape that will assist us connect the wires to our battery. So we are going to have the rods. These are all again improvised. What I did to get these 2 rods that we called the electrodes, I dismantled an old battery, and inside it there is an electrode. So I picked these electrodes from old batteries, and that is how I came up with these 2 electrodes. Now we also learn how to identify the 2 electrodes. We will learn how to identify the 2 electrodes once we put them in our solution. So we start by connecting here using a masking tape. The other one, we put it here. Like that. Put it in place. Then I'm going to put some common salt. This is salt that we use as food additive. We add in our food as we prepare our food. So I'm going to stir to dissolve it. I'm not going to make it so concentrated, so it will be electrolysis of dilute sodium chloride. Electrolysis of dilute sodium chloride. Then we are going to put our rods, our electrodes, in the solution, and since it is connected to a battery, a reaction will take place. And the way the reaction will take place will help us identify which is the cathode and which is the anode. So we are going to put them together. So as we can see, there are some bubbles of gas, of certain gases that are being produced here. One is reacting faster than the other. So this rod this rod that is producing a lot of gas, this one that I'm shaking, it is producing a lot of gas. And there is another one that is just producing a few bubbles, as this one produces twice as much. Now, the one that is producing a lot of gas, this one that I'm shaking here, is the one that is going to be negatively charged. And this one that is producing some small bubbles is the one that is positively charged. The reason we are going to see in our discussion why this one is producing a lot of gas and the other one is just producing a few bubbles. So that is a simple experiment on electrolysis, and you can perform it, you can try it at home. This is a simple experiment that you can try it at home. So we are going to go into the details now of why this one is producing more gas than the other one. So, during the electrolysis of sodium chloride solution, we have identified that we have sodium ions, we have hydrogen ions, we have chloride ions, and we have the OH ions. Now, this one brings us to what we call what makes what ion be discharged at the two rods that we have. Because we know that these two, the positively charged here and the negatively charged here, these will be attracted to the negative rod, and these two are going to be attracted to the positive rod. So once they get there, not both of them are being discharged. It is only one that is going to be discharged. And that is why we come up to a factor, the factors that influence the preferential discharge at the cathode and at the anode. Now we are going to write down the reactivity or the potential series, the electron potential series here of both cations and anions, and we will see why they are discharged in that manner. So the cations, we have potassium ion, we have calcium ion, we have sodium ion, we have magnesium ions, we have aluminium, we have zinc, we have iron, we have iron 2 ions, we also have lead ions, we have hydrogen, we also have copper. I don't know whether we can make them start from a higher place. So that you'll be able to see all of them at once. So we start from potassium, we go to calcium, we go to sodium, then we go to magnesium. Remember, these are cations, the ones that are positively charged. Then we have aluminium, we have zinc, we have iron. After iron, we have lead or lead. We have hydrogen. Then we have copper. We have Hg. Then we have Ag. Then we have Au. Au is gold, Ag is silver, and Hg is mercury. Hg is mercury. Like that. So this is the series that shows us how the cations are discharged. Now this one will have a very high negative electrode potential, or it has a very high standard reduction potential. This one is a very strong reducing agent, and with that it will not accept electrons very fast. Now, the lower the element or the lower the cation on this series, the faster it accepts electrons. The faster it accepts electrons. Then you go to the anions. Anions, we just have a few. We have OH ions. We have nitrate ions. Now, before we go to nitrate, we have the Now, there's a simple way of remembering this. There's a simple way of remembering how the anions and the cations are going to arrange themselves. And I can teach you a simple one. Like for the ions, we normally say, for us to remember the way they are arranged, we normally say, oh, I bought cabbage, not sausage. So once you say that, you'll be able to remember the way these ions have arranged themselves. These are the one we normally say for electrolysis purposes, calcium comes before sodium. But in the other reactivity series, you realize that sodium is higher than calcium. So we'll say popular scientists, you come to sodium, can make a zoo in, remember ion starts with an I, in low, lead starts with the L. Humid is because of hydrogen, country, copper, mercury, silver and gold. So we can do that again. Popular scientists can make a zoo in low, humid, country, mercury, silver and gold. So that is how you can remember the way these ions have been arranged on this series. So let's go back now to our sodium chloride. We said that we have sodium ions. We also have hydrogen ions. Then we have the chloride ions and the OH ions. The OH ions are like that. So when sodium and hydrogen migrate to the cathode, when they go to the cathode, which one will be preferentially discharged, or which one will be discharged at the cathode? It will be hydrogen, because it has an ease. It is easier for hydrogen to accept electrons than sodium because of its position on this series. So hydrogen will be discharged, or it will be preferentially discharged at the cathode. It will be preferentially discharged at the cathode. Then, when you go to OH and the chloride ions, we have the OH here and we have the chloride ions here. So for the anions, we start from up. We start from up here, because we have already come up with the way of remembering the way they are arranged. So for the anions, it is the other way around. The ones that are on top are the ones that are going to be preferentially discharged, and the ones that are lower are not going to be preferentially discharged when they get to the anode. So in this case, we are going to have OH ions being discharged. The OH ions are going to be discharged at the anode. So that means we have the OH ions at the anode, and we have the hydrogen ions being discharged at the cathode. Now, you realize that hydrogen, the OH ions, for them to be discharged, we are going to lose 4 electrons. We shall lose 4 electrons. And here, this one requires only 1 electron. And we know that it is a gas again. We said the other time that gases do not exist, some of the gases do not exist monoatomically, and this one exists diatomically. So we require 2 electrons. We require 2 electrons for it to be discharged. Now, when you compare the number of electrons here and here, this one requires twice as much It requires twice as much number of electrons that are released here. That is why we discovered that at the cathode there was a lot of gas being produced than at the anode, because this one is giving us 4 electrons and this one requires only 2. So we require 2 moles of the hydrogen. For us, we will produce 2 moles of hydrogen with this number of electrons that are being given out at the anode. Now with that, we have been able to identify the cathode and the anode. Now during our next lesson, we shall go deeper into writing or identifying the oxidation and reduction, where oxidation is taking place and where reduction is taking place, and also writing the oxidation reactions equations and the equations that will undergo reduction, oxidation and reduction. So let us meet in our next lesson.